Now let's learn 2's complement. But first, let's see how we represent negative number without 2's complement. Assuming now we have 4 bits, 0, 0, 1, 1. If we try to add them up, we will get 2 to the power of 0 and 2 to the power of 1. If we add them up, we will get a decimal number, 3. But how about negative number? How do we represent them? A straightforward method to do that is to turn our first bit as a sign symbol. We use 0 to represent positive and use 1 to represent negative. So if we try to add them up, we will get the number -3. However, this method is not convenient for calculation. For instance, if we try to add these two binary up directly, can we do that? The answer is no, because symbol cannot be calculated. If we do try to force it to happen, we can see the result will be weird. So let's try. 1 plus 1, we will get 0 and 1 up. 3, 1, we will have 1 here, 1 up, and get down 1. And for this one, 0 plus 1, 1. Why is this number in decimal form? Let's see. So for this one, I get 2 to the power of 1, 2 to the power of 2. For this one, it represents negative. So we get here is -6 in decimal form. What we originally expect is to get a 0 in decimal form. However, if we try to add them up directly, we get a -0, which is wrong. So because of this inconvenience in calculation, we have 2's complement. Assuming on the right, we have the same 0, 0, 1, 1 bits. If we try to add them up, we will get a decimal number 3. So how about the negative number in 2's complement form? In order to represent a negative number, we will turn the first bit as our sign bit. And this sign bit, they are not symbol, they are number. What do we mean by number? Let's try to add them up. For the first bit, we get 2 to the power of 0 and 1, and 2 to the power of 2 to the power of 3. Because this one is 0, we will ignore it. So let's turn our attention here. Because we define this as a sign bit, so if it's 1, we will say it's negative. So for this 2 to the power of 3, it will be a negative number. If it's 0, we will say it's positive. Let's try to add this number up. What we get will be -8 plus 2 plus 1. So the answer will be -5 in decimal form. So what's good about 2's complement? The best part of 2's complement is we can add two binary bits directly. Let's see what will happen if we try to do that. So 1 plus 1, we will have 1 here, 3, 1 here, 1 down, 1 to go, and 1 down here. And we will add 0 and 1 directly. We will get a 1 bit down. And let's try to add this number up to see its decimal form. So for this one, 2 to the power of 0, 1, 2, 3. This one is 0, so we will ignore it. And this first 1, it will represent negative number. So in the end, we will get -8 plus 4 plus 2. The answer would be -2 in decimal form. Is this what we expect? Let's see. 3 plus -5. We do get -2. So the answer is correct. So to sum up, what's good about 2's complement? They can do bit calculation directly. On the right is our sum up for today's practice. So this will be the end of this video.